Hi, my name is Aaron Phelan, and this is my lab report for Lab 1, Charged Tapes. With regards to the description and purpose of the lab, it was to use tape in order to observe the transfer of electrons between surfaces and to calculate an estimate of the charge and number of electrons that were transferred. The fundamentals of the lab were using tape in order to model charges by assuming that each piece of tape had equal distributed charge in order to apply Coulomb's law, using Newton's second law, which is force equals mass times acceleration, and Coulomb's law in order to calculate the charge in each piece of tape, using the approximate dimensions of an atom to calculate the number of excess or deficient electrons per atom on a piece of charged tape. With regards to the results, the charged pieces of tape repulsed each other. The charged pieces of tape were determined to be positively charged. The charge in each piece of tape was determined to be about 1.34 times 10 to the negative 8th coulombs. Each piece of tape was determined to be deficient of about 8.37 times 10 to the 10th electrons. And as you can see, tape A was on the bottom and was what caused tape B to float. With regards to the assumptions and models, as I mentioned before, each piece of tape was used to model a point charge. I assume that air resistance is negligible. I treated a long piece of tape as though it were a point charge with all the charge concentrated at the center of the long tape. I assume that each U-tape had about the same amount of charge evenly distributed along the length of the tape. So with regards to the experiment, I chose the system to be tape B and tape A, and the surroundings to be everything else in the room. So for the initial conditions, it was 2 pieces of approximately neutral tape, also being about equal in length, and a 3rd piece of neutral tape which was stuck down on my desk. So for the details of the experiment, tape B was stuck to the tape on the desk and ripped off quickly in order to charge it, either leaving behind electrons or gaining more electrons through the process. The tape was then hung near several objects to determine its charge. It was finally placed above the other piece of similarly charged tape, tape A, until a portion of it floated and the distance was measured between the tape to calculate tape B's charge. With regards to my observations, I observed that the U-tape was attracted to my hand, it was repelled by another piece of U-tape, it was attracted to a neutral book, and that it was attracted to a negatively charged pen. The conclusion I was able to reach from these observations was that the U-tape was positively charged, and it had lost electrons in the charging process. So with regards to my data and calculations, I was able to determine these measurements for the tape, and using the measurements, I determined first the force of gravity on the tape, which was about 0.00217 newtons. I was then able to determine the charge on the tape, as the acceleration of the tape is 0, so the forces on it must be balanced, meaning that the electric force must equal the gravitational force, since the only forces we accounted for in the vertical direction were these two forces. I was then able to use the equation for the electric force to determine an equation for Q and to solve for 1.34 times 10 to the negative 8th coulombs per piece of charged tape. We also assumed that the charge on each tape was equal. I was then able to use this data to come up with a few more calculations. I divided the charge of one piece of tape by the charge of a single electron to get 8.37 times 10 to the 10th electrons that had been lost per piece of tape. I used the area of the tape and divided it by the area of an atom to determine that there were about 4.21 times 10 to the 17th atoms per piece of tape. And I was able to determine a ratio of 1 electron for every 5.014 times 10 to the 6th atoms with this data. As you can see, I used glow script to model this interaction. Tape B was the red sphere, while tape A is the blue sphere. The orange arrow represents the electric force, while the green arrow represents the gravitational force. As you can see, the forces on tape B are balanced. With regards to some of the discrepancies between the model and the actual experiment, one is that obviously the pieces of tape were not actual point charged, but were just used to model as such, and so there may have been some inconsistencies due to that, and the charges on each tape are likely not exactly equal as we assumed in the calculation. Some potential sources of error were that each tape was not equally charged, meaning that Q may not have been equal for each piece of tape, and our calculations may have been skewed as a result. Another possible source of error is that some charge may have been lost from the tape due to my handling it. What if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? With regards to this question, the observations that I made would have remained exactly the same, as even though the charge conventions have switched in this scenario, it would still interact the same, with like charges repelling and opposite charges attracting. So the charged pieces of tape would still, even though they would have been negative under this charge convention, they still would have repelled each other and they still would have been attracted to the now positive pen. Why is it important to handle the charged tapes as little as possible? What happens when charged tapes come into contact with your hands or other objects? It's important to handle the charged tapes as little as possible in order to ensure that they remain charged. When they come into contact with my hands and other neutral objects, they may begin to neutralize themselves by gaining back some of the electrons that they lost. This would have skewed the experiment results. With regards to some of the conclusions that I reached through the lab, I found that everyday objects can be used to model point charges and observe electric interactions by charging them. Newton's laws of forces can play an important role in determining individual qualities associated with an object, such as charge. Objects can easily and accidentally be slightly charged through touch alone, and electrical forces and fields are an important part of our world that account for many physical interactions that occur. Thank you for watching.